So today we're going to build some battery interconnects for these ALCAD LP200 nickel cadmium batteries. They're rechargeable. They're quite large. And you can see, compared to your hand, these things are about 14-15 inches high, about 6-7 inches deep, and 3.5 inches wide or so. Each one is 200 amp hour, and the nominal cell voltage is 1.2 volts. Now we've got another bank set up here with 10 cells, and they're just charging on the charger here. It was pegging the meter at 25.7 amps for quite a while, so we've just got 10 of them in series, and I think it's about 14 to that now, 14.5 volts for the entire bank. So but what we're missing is we're missing a bunch of these interconnects, so I'm just going to measure up and see if we have some aluminum that we can use. It's not ideal, but it'll definitely get us by for a little while. I think these are either chrome plated copper or stainless, I'm not sure which, and we'll see what we have in the shop. Okay, now we're here in the shop. We've got a battery interconnect here. This one is actually a little bit longer. The actual connections are only about that far apart. This is probably one of the interconnects that's used to go from one bank of 10 to another bank of 10, so it's a little bit longer size. What we got here is some aluminum. It's about I think it's 1/8 of an inch thick, and the dimensions are just over 5 inches wide. So what we're going to do is we're going to cut strips here of 1.5 inches wide, and basically the mark on the saw right at the edge here that lines up, I was going to actually mark the saw but don't need to, is just the right size for that. So we're just going to do a cut here quick. And there we have it, 1.5 inches by 5 1/4 roughly, and we're going to go over, look at the batteries, and we're going to put a mark on either side here where we're going to drill 3/4 inch holes that fit the terminals of the batteries, and go from there. So here we've got the aluminum material in the position, and we're just going to use a marker, and we're going to mark the location of the holes. Now we've marked the center of the holes, and we're going to cut those out with a 3/4 inch bit. So we just put the piece in a vise here, and unfortunately my hole bit is a piece of junk that won't hold the bit, so I'm going to pre-drill the holes here. Okay, we've gone through, and now I just got to put this bit back into the hole bit. And here we go with a 3/4 inch hole bit. Alright, that's one side done. The other side. Alright, and you can see here we've got the final piece. It's actually pretty hot coming out of there. Ideally you want something here that's maybe a little bit longer, but the 5 1/4 inches is all I have to work with, so it's not really that critical that there's a lot of meat on the ends here. It's a little thin on the one side, but you've got a big nut that's on the terminal, so there's quite a big area here. If you're really concerned about amp rating of these bus bars, basically there's lots of formulas on the internet where you can figure out by the width and the length of this what the resistance is of this piece versus using a cable or a wire or something like that. Now we'll go try it out on the batteries. Okay, we want to see if these bus bars fit on here. Just so you're aware, battery is essentially multiple cells. So in this case, this is a cell, this is a cell, this is a cell, And if you put all these together, it's considered a battery. Your car battery, for instance, has 6 separate cells in it. That's why it's called a battery, but technically one of these cells is not considered a battery on its own. So when you're wiring these together, we've got a positive post here, we've got a positive post here, and we've got a positive post here. They have a little X on the top there, a little positive mark. So what you want to do is add the cells together, so you're going positive, minus positive, minus positive, minus positive, and you're putting them together like that. So in this case, we can put one here, and we can put one here. So what happens is, this is the negative post here, and this is the positive post. In this case, it's 1.2 volts, 1.2 volts, and 1.2 volts. So that would be 3.6 volts measured now from this terminal to this terminal. The electricity basically goes through in series all the way through the battery now. And that's the way you hook up, you get more voltage by hooking up more of these cells together. Alright, now we've got a few of these interconnects on here. You can see the aluminum ones look a little different than the plated ones, but same deal. We're just going to stick them between the batteries here. And all that's left to do is get the nuts on here. Tighten all these up, and then we'll get the charger on it. So once you get the bus bars on there, you got to tighten them up. So you need, in this case, it's a 30 mil metric, and you're just going to tighten up each one. And if you're nervous about this, put some tape on your wrench, because you do not want to drop this wrench on top of your battery bank, because you will be doing a lot of welding and or have an explosion. And in this case, these batteries generate oxygen and hydrogen when they're charging, so you don't want to blow anything up. So we'll get them all hooked up here, and then we'll start charging them and see how many amps we're pulling. Well, we just finished charging the first bank here, and they're bubbling pretty good. So I got this new bank together with the bus bars, and we're going to see what we got in there. Move over the negative here. Check the voltage. 12.3, and give it some current. It's the max rating. And as expected, we've pegged the meter, so we'll give those a good charge, and then we'll be playing around with them later. Once again, these are ALCAD LP200s, 200 amp hour, 1.2 volts nominal. They're typically between 1.3 and 1.4 volts under normal use, so 10 of these to get 13 to 14 volts in one bank.